All right, so for these questions we're graphing, and there are different ways to represent the points in a graph. One of them is by a set of ordered pairs, another is by mapping, and another is in a table. In our ordered pairs, we have a left and a right aspect to them. Coordinates. -1, 5, -5 is one pair, 3, 2 is another pair, 4, 5 is a pair, and 4, 7 is a pair. And these are x and y values. That's reflected in the table. X on the left, y on the right, and we have -1, -5, that's a pair, 3, 2 is another pair, 4, 5, and 4, 7. And then when we map them, interesting things happen. On the left, -3 and 4 are what's called the domain. These are domain values. And this is called the range. And how they map is 1 to 1, -1, -5, 3, 2. But the number 4 appears twice in the domain, and therefore it maps out to two different numbers. In other words, two values of y are associated with one value of x. And x, in this sense, kind of splits itself into two different values. When we graph these, an interesting thing happens. We graph them, and we get -1, -5. So -1, -5. Okay? We get 2, 4. We got 3, 2. 3, 2. So over to the right 3, up 2. That's +3 and +2. We go right and left first. Our x values are right and left. Our x values are right and left. So we go to the right 3 and then up 2. Left up and down is the y values are up and down, and the x values are right and left. So to the right 3, up 2. Then we've got 4 and 5. So 4 to the right and 5 up. And then we've got 4 to the right and 7 up. And that's where we have an interesting thing happening. This is a situation which fails the vertical line test. So when I drop a pencil right over there, those 2 points line up on that pencil. That's called a vertical line test. And in this case, this particular relation fails the vertical line test, so we can say it's not a function, all right? It's not a function because it fails the vertical line test. And that's how you can tell if a relation is a function or not. Going backwards to the last question, we had a situation like this where we mapped it out and we had 2 points that lined up horizontally, but that was okay. It's still a function. It's not a function when it fails the vertical line test. In this case, for every point we put our pencil or pen vertically, it didn't cross the other point, as you can see. I can move my pen along here at each point, and it does not cover the other points. That means it passes the vertical line test. See the 3 other points? I put it here, all 3 other points appear. I put it here, I can still see the other 3 points. And I put it there, I can still see the 3 other points. Whereas in this one here, I put it there, yeah, I can see the 3 other points. I put it there, yeah, I can see the 3 other points. But when I put it here, I can only see 2 other points. That means it fails the vertical line test, and the way you can tell is when it's graphed, putting a pen or pencil over them to see if they get blocked or covered. The other way you can tell is when you notice on a mapping situation that 2 y values are associated with 1 x value. The way that shows is that on your table or in your ordered pairs, the x value repeats itself. There's a 4 here twice. There's a 4 here twice. It's a dead giveaway. Whereas in this one back here, the 4 was repeated, but it's in the y value, so it's not going to affect it. Anybody have any questions? Good.